Good morning, everyone. Thought I'd start a little early. Hold on a sec while I, tell people we're live on Twitter. Retweet with comment. It's showtime. Get in the front row. All right. So, how's everybody doing? Glad to see everybody today. All of you fine-looking people. Given Brian Timoney's advice, I have switched my attire to wear something a little more formal, to look perhaps a little better. It's a Wednesday, though. He said something muted. I don't know if this is what he was thinking with muted. I looked through my closet, and I figured this was kind of a muted red color thing for me, so this is what I put on. Hope you like it. Morning, Dana. You like it, Timothy? Good. I'm glad I got your approval. Because your fashion sense, those khaki cargo shorts, us older gentlemen in our cargo shorts and our t-shirts, we have great fashion sense. Oh, little known fact though. Pleats in the front. Helping pudgy men out in no way since forever. Little known fact about me, I was voted best dressed in high school. This is not a joke. I was. I think that says two things. One, it tells you about how guys used to dress in my high school. I don't think I had that high of a bar to exceed. And two, I used to care a lot more about how I looked in my clothes. It wasn't like it's not like a suit and tie kind of high school guy. That doesn't what they mean by best dressed. I was kind of for those of you who grew up in New York, I listened to WLIR, which was the alternative radio station, and I had to climb up onto my roof and put the antenna on and everything just to get it, because I didn't actually live in New York City. I lived in a northern suburb. But like normal radio wasn't playing The Cure and wasn't playing the Smiths and wasn't playing Oingo Boingo and all that other stuff. So I really needed that music in my life, and so I kind of somewhat dressed that style, right? So like I would go into the Village in New York and buy like chemical warfare pants, like the baggy things you would put over them, and wear those. And I had like a Bundeswehr tank top like the cool Londoners did in their music videos, and like I think Depeche Mode had one of those. Anyway, so I wore some of that stuff to school, and yeah. Oh, my favorite thing was like I had a jean jacket that had all the brown leather tassels hang over. It was like a washing machine when you wore it. It was so much fun to wear. It was like the George Michael jacket in Faith. All right, well, that's enough about me and fashion. Thought you would appreciate that. The other thing is I am curious if anybody has started watching Dave on Hulu and what their thoughts are about it. I'm telling you, it's a really good show. Also, with Westworld, you can just pick that up now in this new season. You don't you kind of need to know a little bit about stuff before, but you can just kind of, it's almost like a totally different show. It's still a good one, but you can kind of pick it up now. Watching His Dark Materials on HBO with my kids. It's an interesting interpretation. It's a little bit more truer to the book than the movie was. And then that's about all the shows. Video gaming, I'm basically doing Call of Duty Modern Warfare all the time. Warzone with some friends now, because it's free, so now they're playing, but that's the only video game I'm really playing most of the time now. With that, about the stream, I'm going to probably figure out something new with the camera. I don't like the way this camera is working out. Okay, and that's it. Let's go on and start doing what I promised everybody for today, which is JSON in PostgreSQL. So the idea with this is most people think when they have JSON in their application, they need to go to Mongo. That's it. JSON, Mongo. Got to use Mongo. It's actually not true. You can actually use PostgreSQL for most of the stuff that you want to do with JSON. It's actually quite capable. And then you don't have to add another piece of infrastructure to your architecture, and you can feel like your data is going to be safer. So let's go through and just do it. Sound good? Of course it sounds good. Let's see. So we're going to now, let me go back to OBS Studio and switch to, I think we'll do full so you can see me at the same time. So right now I'm at learn.crunchydata.com. And then what we're going to do is we're going to go to PostgreSQL for application developers. Learn.crunchy, we're going to go there. Learn.crunchydata.com is a learning portal that we have put together. It has a whole bunch of hands-on tutorials that you can use at any time. It's available 24/7, free of charge. At some point, we might start asking people for an email address, just maybe to send you a monthly newsletter or something like that. But right now, if you don't want to give us your email, get all your learning in. Not that we would spam you or anything like that, just probably in a monthly email. But anyway, so we've put this together, and it's got a whole bunch of stuff. Oh, I know I have a lot of GIS heads in my video. We have a whole class on PostGIS. This is like a big PostGIS course. Look at all that stuff we got there. It's based off of the in-person workshop that Paul Ramsey and others, myself once, back at, what was it, GeoWeb? Back in Vancouver, British Columbia. Was it called GeoWeb? I think that's what it was called. Anyway, this is based off of some of the workshops we did there. So if someone in your life wants to learn more about PostGIS and you don't want to do all the teaching yourself, you can just put them here, and it covers a lot of different topics. And then we're going to do PostgreSQL for application developers. We're going to go to beyond PostgreSQL basics for developers. And then we're going to go to quick intro to JSON in PostgreSQL. And so the way all of the Learn classes work is there's a little intro, just tells you something about the data. We're going to be working with natural event data from NASA. And in this case, natural events basically means bad natural events, not just any natural events, but bad things. They have a JSON API, but I was trying to look for a good JSON data source that's public domain, and this is the best I could come up with. It's got a little bit of hierarchy in it, so you can do some fun navigation and stuff like that. And we're spinning up, remember that last session where I showed you at the end how to spin up a PostGIS or PostgreSQL in a container? We're actually spinning that up in the learning environment. The database is going to have a username where the user we're going to use is Groot. Again, from like you saw that in the last session. Sorry to the other person who commented that the password should have been I am Groot. That is, you are correct. That should have been. I don't know what I was thinking, but the password is password, and the database name is Workshop. All right, and we're not going to go in depth today. We're just going to do a nice short little talk and just show you how it works. So start the scenario. So it's already got the database up and running. Actually, it turns out that PostgreSQL has 3 types that can function somewhat similarly. The first type I'm going to talk about is JSON. You basically want to ignore that type. So actually, let me open up. Do I want to open up code, or do I want to open up? Let me open up code. So let me close that. You can close that. Just make a new doc. Okay. So there's a JSON type, and you basically want to ignore the JSON type. The JSON type, the only reason you would use the JSON type is if you just wanted a blob, right? We don't actually need it. The JSON type, it doesn't actually do anything good with JSON. It's a very old data type that was when JSON was like first starting to come around, and it's just basically for plowing JSON in. Can't do much with it. And you definitely can't index it, which makes it kind of not that helpful. So skip the JSON type. The other type is an HStore, and spelled like this. Oops, should be here. The type is HStore, right? HStore is for storing arbitrary key value pairs in a datum, right? So datum being, think of a row, think of a row and a column, and when they come together, that's a datum, right? So it's under data value, and inside of that, you can store arbitrary number of key value pairs, right? That came out after the JSON type, but before the type we're going to use today. It's not deprecated, but there's no new development on it, right? Nobody's doing any new development work on HStore, and if you think about it, a JSON type, like JSON is basically a key value store can basically be like a one level JSON type, right? So we have name value, right? And then you do your next one, right? And so that could be key. You can think of it like key value, right? So that is basically the ability to one level JSON document is the ability to store arbitrary key value pairs inside of a data type. So I don't recommend using HStore if you need arbitrary key value pairs. Just do a one level JSON document. Okay. So with that said, the type we're going to be using today is JSON B, right? And that's what, and the B here stands for better. No, it stands for binary. And what that means is when we take the JSON and we turn it into binary format and we process it and actually turn it, we being me being the PostgreSQL database. That's what we means in this particular instance of we. So Postgres, when it takes it in, turns it into binary and processes it, right? There is no schema, so it doesn't do any validation checking and make sure it's well-formed JSON. But other than that, it doesn't really do anything else. But the nice part is we can have things inside of it. It's not just a big blob text field. You can have things like dates being dates, integers being integers inside of it. And we can index it. And the index type you're generally going to use against JSON B is gin. I should open code again so I can show you what I mean, but I can type that out. And it is just like you expect it to be spelt. Let me get rid of all this. Boop. It's gin. And I forget what it exactly is. It's generalized inverted something or other, I think is what it stands for, right? Or generalized index something. I don't know. But it's lossless, right? The other one, which the GIS heads should know, is gist, right? Gist is what PostGIS uses for storing, making its index on geometries. Gin is lossless. Gist is lossy. Because if you think about it, when you make a gist index, you take it and you take the polygon, whatever shape it might be, and you make a bounding box, right? So we've lost a ton of information, but we made a nice little fast index. Because for our search purposes in the index, we don't need the exact geometry. The bounding box is what we're going to use. Anyway, so we're going to use gin today. All right. I'm not going to do this quick note. I'll talk about that in a little bit about why later. I just want to show some stuff first. But I want to talk about why. Maybe I'll do that at the end. After I show you what you can do with JSON, I'll talk about maybe why you should try not to use straight JSON in your data. It's an interesting discussion. And having that discussion inside of Crunchy was very interesting, given that we have a lot of Postgres heads. All right, so let's go ahead and log in. Right? Again, you can click on these black boxes. Remember, I've never told you this before because I've never used learn.crunchy data here before. But when you click on a thing and it pastes it over into the terminal, it doesn't actually switch focus. So you can start typing and you hit enter and nothing happens. You're like, what's going on? It's because focus hasn't changed. You have to click over here. And the password is password, though it should be I am Groot. And the data table is going to be called natural events. So let's look at natural events. What the table contains is an ID column. It's just text. And we also have a JSON content. And the type is JSON B. Right? This ID is actually the ID value that when I made the SQL, I pulled out the ID from the JSON content and I pushed it into an ID column so that we could have we could actually do foreign key relationships and fun stuff like that. The primary key has a normal just primary key B tree, but on the natural events, on the JSON content, we did a gin index, right? And so let's see, what else are we going to do? We're going to do querying. One thing before we start querying the JSON is I want to talk to you about differences in the operator. Before I get to differences in the operator, this is Postgres 11 that I am showing today. Even though the server is 11.2, right? With Postgres 12, there is a new JSON SQL, I think it's called SQL standard for JSON Path or something, or for JSON or something like SQL standard for JSON, which has JSON Path expressions. So for those of you old timers who used to use XML, when we had XPath, which made it much, much nicer to navigate XML documents, this standard provides some of that same type of syntax, or at least search dynamics, for JSON documents. So I'm not going to show that today because it's not in this scenario. That is in my to-do list to update this to show 12 stuff. So today we're going to use the JSON search capabilities that were in 11, which the Postgres group came up with themselves. The good news is it looks like the SQL standard group got a lot of ideas from the Postgres JSON search implementation. And so a lot of the patterns look very similar in the JSON spec. So your information's not, learning what you're learning today is not going to, you don't have to totally relearn everything to do it with 12. But in a future one, I will show 12, okay? All right. With that caveat out of the way, there are two types of operators. Usually there's a single arrowhead like that and the double arrowhead when you're asking for something. So this first statement, we have a value and we're saying this text string of curly brackets, a value, close curly brackets. We're telling Postgres this is a JSON type. And if we say, I want the value of a, the single arrowhead, it's actually going to return the value as JSON. If I use a double arrowhead, like the one I have highlighted, that's actually going to return the value itself. No more JSON. And you go, oh, well, why is that important? Well, just like in Python and lots of other programming languages, you can chain these operators together if you have JSON values that come back, right? So if you give back JSON, you can then either use a JSON function on it, or you can chain other navigation operators that respect JSON on top of that as well, right? So that's the difference. So if you see a single arrowhead or a double arrowhead, it just changes the values. This below is what some of our JSON looks like for today, right? It's got at the top level, it's got ID, the link to the data, the title, the sources, like where did it come from, what categories it's in, the geometries for it, and the description. And the description, I think, for almost all of these is blank. All right, so if we wanted to get the title from one of these, we're going to do this, right? This is going to be get the text value of the title. We do this, bloop, and we say select from the JSON content field the value for the title name, right? The title name attribute of the name, or the name attribute pair, right? So from natural events, limit 1, and it gives back wildfire, Sardinia, Italy. And we have this nice header, isn't that nice? We can also use the JSON path operator. So this is the JSON path operator here, and it's basically saying, go into the JSON document and just get the top level title thing and give me the value back since I've got double arrowheads. Right? So I click on that and we get the exact same response. This one is saying I want the actual JSON back, and so we do this one and we get back. Now you can see it's got the quotes around it because it's actually a JSON value. Right? So that's just some very simple, give me something from a JSON blob, which is actually powerful enough in itself. Sometimes people, that may be all you're doing, right? You're storing JSON in and you're like, I just want to pull out values as I get it. Usually that's not as much as people want to do with JSON. So we'll move on to other stuff. A little hint for all of you Linux. This probably works on Mac too, although I almost never use Mac. Control L clears the screen and brings the cursor up to the top. So let's clear the screen and go on to the next one. Oh, and if there's questions, go ahead and put that in the chat on the left side. And then I'll try to answer them as they go. I know there's a little bit of lag, but I've set the YouTube stream to very low latency. So hopefully I'll see the questions really quick. Okay. And I like questions, just so you know, I really like questions because it gives me a sense of what you folks in the audience are actually feeling and seeing and understanding. And if I'm talking too fast, I have the sense I'm talking too fast. I didn't have any caffeine this morning, but I feel like I'm talking too fast. Let me know if I am. All right. So now let's actually do more than just grab a top level item. Let's navigate down a tree, right? And so remember before there were categories for the events. And so what we're going to do here is we're going to go into categories and pull out the title, right? So this is the way the JSON path works. We're going to say, select from the JSON content. We're going to get, since we have a double arrowhead, we're going to get back the value, right? And what we're going to do is we're going to say start at categories, go to the zero. See, there's an array here. Notice there's an array. So we're going to say go to categories, get the 0th element in the array, and then grab the title from that 0th element in the array. Right? So that's categories, go into the array, get the first, right, the 0th element, the 0 position element, and then grab its title. And we're going to say give us back 10. And there we go. We got 10 different values back. Wildfires and severe storms. Right. And so that's how you can do JSON navigation, like navigate into a JSON document. Now, what I want to show is that you can actually combine normal SQL with all this JSON stuff. So this is one of the great parts about having JSON in Postgres rather than moving to something, say, like Mongo or something else like that, is all that knowledge you've built up already around SQL and how to do things in SQL. You can just take that and apply that to what you're doing with your JSON as well. So a very common query that you do when you're doing data cleaning, or when you're just trying to get a sense of your data, or maybe even you're trying to dynamically generate a dropdown for people to choose from, right, in your web content, is distinct. So what we're going to do now is we're going to try to get all the different titles for the categories of severe storms. So we're going to say select distinct on that exact same JSON we did before, and it gives us this, right? And then we can see there's only 4 types: severe storm, volcanoes, sea and lake ice, and wildfires. And this is also nice for data cleaning, because you can be like, oh, good, there's no typos, right? Like no one did severe storm and severe storms, right? And then, so it's I love that I can combine the SQL stuff, and I know how to think in that, with the JSON stuff. Like I don't have to figure out something weird do some sort of processing on my end to like put it into a hash and then get, because dictionaries, the keys in that dictionary are unique. So, but anyway, I love it. So so far all we've been doing is dealing with JSON in the select part, the beginning part of the query, what we're going to display. Now let's actually see how you can actually query based on what's in your JSON. So, we still need to know our path expression, but it gets exciting. So let's clear the screen again. All right, so volcano, we're going to look for all the events that have a type of volcano, right? We want to see all those. So the query looks like select JSON content. So this time I'm just going to return all the JSON content, all right, from natural events where. So the first part is you're going to have to navigate to the fields you want to query against in the JSON document. So here we're going to say we want to go into the JSON content. Now notice we're only using a single arrowhead. So we want to return JSON from this because we're going to do a JSON operation on it, not the value. So we say go into the JSON content field, go to categories, and go to the 0, the first element in all of the arrays, the 0 index of all the arrays. And this is a containment operator, right? And it's saying that contain this JSON fragment, or this JSON document, you could say. It's a very small document, but this JSON snippet. And it's saying, so we're saying get all the array elements that contain title of volcanoes. And we're going to return 5 of them. And because these are big documents, we get to see this little lines and everything. But then you can see here's one element with volcanoes. Here's another one with volcanoes, right? So volcano, volcanoes, 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 volcanoes. So that's actually how you can use your select. Right? It's called a containment. There are other kinds of ones that you can do. The other thing to know about this is this could be like a full, complete document, right? It could be something like someone's name and address and like multiple levels of hierarchy. So you can say, if you have a very deep JSON document, you could say, go and grab the person, and where this person contains this entire document, that's in a match, right? You can do something like that. All right, so let's go on. Clear the screen again. Now we're going to do some more advanced stuff. So I want to show you how to do updates. And so the update is, we're going to now do a very typical query that we also do when doing data cleaning, or getting to know our data. It's the same as that distinct before, but we're going to also throw in a where clause, but we're also going to throw in a group by. So select JSON content, right? We're getting the text value back. We're getting the titles. And this time I don't want that weird name on it anymore. We're going to say it's title. So we're going to get the titles. And then we're going to get a count of the primary key, but we're going to group by the titles field. So here again, we're mixing our SQL with our JSON. So we just use our normal SQL syntax. Oh, I know how to do a group by. I want to group by whatever the value is of the title field, right? You don't have to figure out some sort of weird JavaScript format or anything like that. It's just your normal, you work with it with a SQL idiom to get the behavior you want. So let's go ahead and do it. And there you go. And now we can see that we have 3 severe storms, 36 volcanoes, a lot of sea and lake ice, and then a lot more wildfires. All right. So I've lived in California now for 15 years, almost 15 years. And I've developed certain sensibilities, and I have decreed that severe storms is a bit harsh terminology. It might hurt some people's feelings. So I've decided I really want to reclassify severe storms. I mean, that's not a very empowering term to use. So we're just going to call it bad weather, okay? So I want to change all these severe storms to bad weather. And so this is what an update statement looks like. And so we're going to say update natural events, set JSON content equal to. So we're going to say, this is normal SQL, right? Update natural events. We're updating that table. We're setting the JSON content field equal to, and here's a new function, JSON B set. And what it takes is, what's the JSON you want to update? Where you use JSON path to say what you want to update. So we want to update the titles, and we want to set the titles equal to bad weather, right? So if we just left off the where clause, we would set everything to bad weather, which we don't want to do. So we're going to say where, and then we're going to use JSON content. This is the navigation we did in the previous exercise. The value category 0, the 0th element, contains title severe storms. All right. And so we're going to go ahead and do that. And we can see we updated 3, which is good because there was 3 severe storms. And if we look at our new results, boop, you can see we now have bad weather rather than severe storms. Nobody's sensibilities are offended. We haven't been too abrasive to people, right? Or aggressive. So I feel much better about that. And so that's how you can do updates. And I can't remember. You could use, so the Brian Timony asked, could you use JSON in a spatial filter? Thanks for that softball, Brian, even though I didn't prompt you for it. The great part about this JSON, though, is that you can use all of the same stuff with all the other extensions in PostgreSQL or PostGIS, right? So yes, if you had a spatial data type in your table along with your JSON content, you could actually do that exact same thing, right? You could say, I want where these polygons are within X distance of these of my central location point, and where the polygons have this JSON content equal to Z, right? And that's the beauty of having of having JSON in your Postgres database, is you can combine it with all the other goodness that you love in Postgres. You can get all the transactions, you can get all the data security, you can get all the ACID compliance. I mean, you can't actually get it you can get actually transactions around putting your JSON in. You can't get any schema validation though on your JSON, right? So that brings me also to the second point, and this is what I said I'd hold for later. So I've shown that you can put JSON in, you can do a bunch of stuff. Look, if I show you, there's a full page of JSON operators and stuff that you can do, right? So here's all the operators. There's a whole bunch of fun little functions that you can use against it, right? Like there's like a JSON pretty or something like that. Let's see if we can find it. Pretty, right? So JSON be pretty. So what we could have done instead of what we did before, let's find that one where we return, that's update. Where's that one? Right. So here's where we returned all those volcanoes. We could have done, I think it was JSON be pretty. Is that right? Yeah, JSON be pretty. So we could have done this instead. Oops. Underscore in the wrong place. Right, and then you get back the pretty print JSON. There's all sorts of really fun stuff you can do with the JSON as well. So despite all this really cool stuff that you can do with JSON, I do want to caution people about relying on JSON too much as a data store type. So there's a couple different reasons. Let me go back so I can remember them all, so I don't skip any because they're important. So one of the things that I want to point out is JSON B storage can be several orders of magnitude larger than if you actually have a well-designed data table, right? And the reason, and so you say, well, Steve, storage is cheap. Who cares about storage, right? I don't care about it from a cost in terms of money perspective for the most part. What I care about for you is that when data grows in a database, it takes longer to get it and to process it, right? And so your operations become more expensive, right? The more that your database has to pull data off disk, or if you're still using spinning disks with your database, but even with SSDs, it still has to jump around to get the data. The more it has to jump around and move to get the data, the longer it's going to take to return your queries, right? So, and the reason why it's bigger is, right, because each one in a normal well-designed table, each of these is just some metadata on the table. It's just the column header, right? All these names are all just top-level table items, right? They're just the column headers. But in JSON, you're going to have to store every single one of these for every single document. So it can quickly add up, right? You lose the ability for the database to enforce proper data types. There's nothing right now in JSON to have somebody type in ID 12 and then someone to type in the next one to type in ID 12 TWELVE, right? And that is a big problem. That's irregardless of Postgres or anything. This is just problems with storing data in JSON. You have the same problem in Mongo. Mongo can't enforce data types because JSON doesn't do that. It just lets you put in whatever you want. So you can end up with a real mess in terms of your data. You also lose the ability for data to keep track and manage relations, right? So there's an ID here. I could go in and change that on my own in the JSON. And if there's children documents somewhere else that refer to this, there's no way to say, yeah, you just created a bunch of orphans, or you can't do that because you have relations or anything like that. You can create all sorts of orphans. And that's some of these things that I'm talking about. I think that's actually the most important reason why. For most of us, we spend most of our time cleaning data. That's actually what most of us, and large chunks of our time are spent cleaning and making sure data is clean and good, and we can use it properly and it behaves the way we want. And a database is really, like normal SQL tables, is really good at keeping it that way once we get it that way. I mean, you can still, if you really try hard, you can still mess up your data. No one's going to stop you from doing that. But if you don't try hard, it does a really good job of keeping your data clean and keeping relations clean, like a good data model will, right? And so I really encourage people to try to, if when possible, yes, you may get your data as JSON, but if you're always getting the same type of documents over and over again, try to process it on the way in and actually put it into a nice data table to keep it that way. I do also realize, having written plenty of applications myself, you don't always control the data coming in, right? Or, so there's no way you can make a schema, right? And so you're like, I don't know what's coming in. I can't. What I'm going to do is just take it, store it as JSON, and then when we start to do stuff with it for real, maybe I'll clean it up and then put it into a table or something. Or it's just easier because I've got all these people and I'm just storing it for them and I'm going to give it right back to them or something to just use JSON. The other reason I've seen this happen a lot is you have a product manager or business line leader who keeps changing the requirements all the time, and you have it's really hard based on your the politics in your company or the way your things are set up for you to actually change your schema rapidly and move it around, right? Or maybe you're doing a whole bunch of, like, you're using Hibernate or something else, so you don't want to. That causes a lot of code changes a lot. So you're like, I don't want to deal with all that code churn right now. I'm just going to store it in JSON, right? I could see that reason as well. So I'm more of a pragmatist. I mean, do what works for you, but I would encourage you to try to use as much as you can, use a good data model. So for example, if I was doing this myself, I might leave the sources and categories alone, not process it. What I probably do would be to pull ID out into its own column, like I did. I'd probably pull link out, because that's actually pretty important and might want to refer people back to the original data. And then I would probably pull, this looks like some nice GeoJSON here, right? So I would probably actually pull these geometries out and the date. I'd pull both the date and the geometries out. I'd put the date in a date column so I could do nice queries against it. And then I'd pull the geometry out and put that into a point type in PostGIS. So I could actually do, like Brian suggested, some nice spatial operations on it, okay? I don't think so go play with the functions. I don't think there's much else to talk about here. I think I'm all done. And I promised I would keep this one short because I'm already at a half hour, so I'm 2 minutes over. Oh, but I did talk about Dave and all that other stuff at the beginning. So, the data I used for this is available here. We have a crunchy demo data, and here's the data. Actually, now I've done a new release on this data. So if I go to the data, you can play with all of our data. It's all public domain. I make sure to do that. I just ship a PostgreSQL dump file. So it's got a bunch of different data sets here if you want to play with it. Some of them are the census data. I don't think I've put in there yet, but we got county boundaries. I have not done county topology or natality. There's natural events, there's storm event data, and Wikipedia data. I have natality and census data done. I just haven't done. Oh no, not census data. County typology. County typology is like, is this a recreational county? Is it a poverty county? It's mostly true-false values for most of it. Natality is all about birth and death rates. No, birth rates. Sorry, just all about birth rates, like the birth average age of the mother, what's the average birth weight, all this other kind of stuff. So I'm trying to put together some fun public source data sets so that we can do fun stuff with, and that we can always refer to. All right. So with that, I'm going to wrap up this stream. I think Friday I'm going to do full text, which means on Friday, we're going to do this quick intro to full text search in PostgreSQL, which is fun. So I'll hopefully see you on Friday. Have fun, people, and stay safe out there. Bye.